a review of the chemistry. So for today, we'll be discussing all right. So again,
Ma'am?
Kain mo itong planggana dito sa harap ko. Tinarang mo naman dito sa daanan. Parang ang ano eh.
Ma'am, wala pong audio.
hindi talaga ako nagsasalita kasi chinecheck ko yung mga pumapasok, yung mga nagpapa-admit. Okay, anyway. So, saglit lang ha. Saglit ulit. Alright, so polymers. So, what are polymers? So, ito yung mga example ng mga polymer materials. Now, by the way, class, di ba yung last time, ang diniscuss natin ay chemical bonding at saka electrochemistry. So, ang next cluster ng topic natin ay materials. So, under materials, meron tayong metals. Okay, metals at saka so, isa doon, metal. So, isiningit na natin yun yung corrosion of metals kasi supposed to be that topic, corrosion is under electrochemistry. Nilagay ko lang siya doon sa metals para at least mas, kumbaga, mas related yung dalawa, no? And then, another under materials, polymers. So, eto na yung mga example ng mga materials classified as polymers. So, classification of polymers, we have based on origin of source, based on structure, okay, based on molecular forces, and then based on mode of polymerization. So, ito yung mga different classifications of polymers. What are polymers? Polymers come from the Greek word poly, meaning several, and meros, meaning parts. So, meaning polymers, meaning it has many parts. No? Many parts. So, these are actually large molecules consisting of repeated chemical units. So, ang tawag natin doon sa mga chemical units is what? They are mers. So, joined together like beads on string. These are large molecules. The term polymer is a general, no? General term. Okay, general terms. So usually contain many or more than 5 monomers. So many or more than 5 monomers, and some may contain hundreds or thousands of monomers in its chain. So ibig sabihin, if it is polymers usually contain many or more. So if it is already contain more than 5 monomers, then we can classify that as polymers. Although, kadalasan na natin are what? Those that contains really a great number of monomers. Ay, okay, so next we have Okay, the small building block molecules are called monomers. Ito yung mga single unit. Single unit that were joined to form, polymers. So, ang tawag natin doon sa single unit is the monomer. Okay. So, halimbawa, dito sa nakita dito, it has what? It has 5 monomers. No? This polymer has 5 monomers. Okay, so again, kahapon, we already discussed the organic chemistry. Diba? Organic chemistry, which is the simplest compounds of carbon is we have the hydrocarbons. Meron din tayo ng aromatic, di ba? Aromatic. Pag aromatic, meron siyang benzene ring. And then these are the straight chain hydrocarbon. Pag sinabi natin hydrocarbon plus carbon and hydrogen. Although the hydrogen may be replaced by nitrogen, may be replaced by oxygen, or it can be replaced by the halogens. So alkanes, alright. So, alkanes, single covalent bond. So we have methane, ethane, propane. Ang ending nila ay, ending ng pangalan nila ay A and T.
Kasi namin ang ulit rin, nag-online, hindi na ituro.
Okay. Then we have the alkenes and alkynes. So alkenes, those that have double bond, and then triple bond for alkynes. So kumbaga, ang pangalan nila ay nakaano din. Alkene, ang ending ng mga pangalan nila ay ENE, and then alkyne, ang ending ng pangalan nila ay YNE. Although this one, acetylene class, acetylene is a common name, di ba dun sa welding, oxyacetylene. So yung isang gas doon is acetylene. Although ang ending ng pangalan niya ay ENE, it is actually an alkyne. So ito lang yung kasi yung kanyang common name, yung mga nakasanayan ng pangalan. Okay, so alkene, alkyne. Then we have the aromatic. Aromatic, also known as arenes, are chemical compounds that contain conjugated planar ring system. So ito yung kanyang formula. No? Either this one, so this is the structural formula. Ito yung mga shorthand formula. No? Symbol for benzene. So, again, hydrocarbon, o natapos na natin ito kahapon. So, butadiene, because it has 2 double bond. So, the 1 and 3, yung isang pag 1, 3, ibig sabihin, dun sa una, may double bond, sa pangatlo, may double bond. So, that's why we have 1, 3 buta, and then we have the prefix di, indicating that there are 2 double bonds. Okay, so yan. Then we have the aromatic. Okay, tert butyl, ethyl group, ethyl benzene, methyl benzene, chlorobenzene. Okay, ito yung mga halogen. If one of the hydrogen is being replaced by chlorine, so ang pangalan na yan ay chlorobenzene. Aniline. Okay. Then we have the ortho para meta. Okay. Ortho para meta. Methyl group. Okay, this one is toluene, aniline. Okay, so saturated. Saturated hydrocarbon, all bonds are single ones and no new atoms may be joined without the removal of others that are already bonded. So, di ba, meron tayong tatlo, the alkane, alkene, and alkyne. Ang single bond doon ay the alkane. So, sino yung last? Bravo. Okay, so, so, ito yon. So, single bond, kaya siya considered as saturated. Kasi lahat na ay bonded with other atoms. So, saturated siya. Maliban na lang, it can still combine with other atoms or other compounds. Pero kailangan may matanggal na doon. Let's say one of the hydrogen may be replaced by other atoms. No? Like for example, this hydrogen may be replaced by chlorine, or it can be replaced by what else? Fluorine or bromine. So, pag halimbawa itong hydrogen napalitan ng chlorine, then it will be what? Ito na ngayon yung kanyang chloroethane. No? Pag bromine, bromoethane. Kasi nga ethane because you have single bond. And among those three, alkane, alkene, and alkyne, ang alkane lang ang classified as saturated. Okay? Classified as saturated. Then, of course, the double bond and the triple bond, the alkene and the alkyne are considered as unsaturated. Okay, so si double bond at saka si triple bond, ito yung considered natin as unsaturated because they can still what? They can still or they are still capable of forming bond with other atoms or with other groups. Okay, so ito. So open pa siya for additional bonding. So ang tawag ay unsaturated. Okay, next is, so meron tayong saturated, unsaturated, isomerism, di ba? Isomerism, ito yung mga compounds na they contain the same kind of atoms and they contain the same number of atoms. Kaya lang, magkaiba ang kanilang structure. So as we have discussed yesterday, since they have different structures, magkaiba rin ang kanilang property. Okay, like for example, ang boiling point nila ay boiling point pa lang magkaiba na. Okay, so yes, you have butane, boiling point, specific gravity, magkaiba din. Solubility in alcohol ay magkaiba din, no? So, ito yung isomers. Parehas sila ng ano, pag isulat natin yung formula nila, parehas silang number of carbon, parehas silang number of hydrogen. Pero magkaiba ang kanilang boiling point. So, yung dun sa, ibig sabihin, dun pa lang sa structure, nagbibigay na siya ng, tawag to, pagkakaiba ng properties ng dalawang compound. Okay, so, specific gravity, magkaiba din. Of course, insolubility in alcohol, magkaiba din. So, stereoisomerism. So, what's this? Denotes the situation in which okay, denotes a situation in which atoms are linked together in the same order, head to tail, but differ in their spatial arrangement or differ in their position, no? They differ in their position. So, head to tail. So, meron tayong tatlo dito, isotactic, syndiotactic, and atactic. Okay. So, ano yung tatlo na to? So, for this one, isotactic, all our groups are situated on the same side of the chain. Okay, they are situated on the same side of the chain. Now, pag ganito class, pag ganitong structure, yung dark na yan ay nakaharap, no? Yung etong ganitong symbol ay nandun siya sa likod, kumbaga. Okay. So, pag tinitingnan natin yan, malapit sa atin yung R, yung H nandun sa bandang likod, no? So, magkakatabi yan. So, that is the isotactic arrangement. All the R groups are on the same side of the chain. Okay? So, kumbaga dito, nakaharap sa atin yung lahat ng ano, at nandun sa likod yung hydrogen. Okay? Then, next is we have the syndiotactic. Okay. So, R groups alternate sides of the R groups alternate sides of the chain. Okay, alternate sides of the chain. Okay, so nakikita natin yan. Alternate. So, yung kanina, ano ba yung kanina? Magkakatabi. Okay, so nakita niyo magkakatabi sila. Yung dito sa pangalawa, alternate. So, carbon and then another alternate. Okay. So, that is the syndiotactic. And then, we have the atactic. Okay, random orientations of groups are along the chain. So, ito yung mga different situations na tawag ito, naka-attach yung ating R. So, the isoatactic. Okay, for atactic, the linear and two-dimensional schematic is this one. So, consider two carbon atoms bonded by a double bond in a chain, H atom or radical. Okay, hydrogen atom or radical, di ba yung naalala nyo pa yung radical kahapon? You have the alkyl, the methyl, ethyl, okay? Bonded to these two atoms can be on the same side of the chain or it could be on the opposite sides of the chain. So, ito yung sinasabi niyang same side of the chain or it is in the opposite side of the chain. Okay, same side, ang tawag natin dyan is cis. Pagka opposite side, ang tawag natin dyan ay trans. So, cis polyisoprene, ibig sabihin, same side, na? So, cis structure. Okay. Let me see kung nandito. Monomer. Wala. Okay, wala kasi yung nakaano dito. Kung eto naka-slant konti class, parang lumalabas dito para siya yung boat at eto naman yung parang upuan. Na? Kaya ang tinatawag minsan the cis entrance or the boat and chair na structure na tinatawag nila dyan. So, boat and chair. Pag nakaangat ito, mukha siyang boat, pero ito naman mukha siyang upuan. Okay? So, cis entrance. Same side, opposite side. Next, we have polymer molecules, macromolecules. The molecules in polymers are gigantic in comparison to the hydrocarbon molecules already discussed because of their size. So we started from a simple hydrocarbon and then we go to polymers na. So monomers refers to the small molecules from which a polymer is synthesized. So next is the chemistry of polymer molecules. Okay, so that's why class kahapon we started discussing about organic chemistry para at least merong background dito sa mga ethene at saka mga polyethylene. So ethene, ito yung polyethylene, ito yung pinagdugtong-dugtong na ethene. Okay, pinagdugtong-dugtong na ethene. So bakit nga ethene? Kasi nga it is an unsaturated and it can readily form bond with other atoms or other alkyl groups. So, ito si atom or alkyl group. Okay? So, makikipag-join siya dito. Okay? So, pag nakapag-join siya, ito na ngayon ang nangyari. Okay? So, i-discuss natin sa susunod na slide. So, covalent attachment. So, usually, for these polymers, they are what? Covalent attachment. So, covalent, it is sharing. Okay. So, again, ito na ulit yung na-discuss natin kahapon, functional groups. So, yan na-discuss natin kahapon ay hindi lahat ito, no? Hindi lahat. Ang giniscuss na natin kahapon yung kadalasan na na-encounter natin. Okay, alkyl. So, ito yung alcohol, ether, epoxide, haloalkene, aldehyde, the ketone. Okay, so alcohol, example, ethanol, methoxyethane, oxide, asan pa? Ethanol. Pag ethanol, alcohol, pag ethanol, it is an aldehyde. Okay? Pag methanol, that is alcohol, methanol is an aldehyde. So, doon pa lang sa pangalan, no? Propanone. Alright. So, hydrocarbon, tapos na natin to kahapon. We're done with this. Butadiene. Okay, 5-methyl, 2-heptanol. So, again, 1, 2, 3, 4, 5, 6, 7. Kaya, pitong carbon, kaya we have hepta. In the second carbon, you have the OH. Functional group. Okay, so, carboxylic acids. So, functional groups in monomers and polymers. Asan na? Okay, so the compounds having reactive functional groups like OH, NH2, and the COOH, etc. on the extreme ends of the chain behave as bifunctional monomers. Okay, di ba yung mga OH, ito yung mga alcohol natin. And then you have the NH2, the amine, and then the carboxylic acids. Okay, so ibig sabihin extreme ends of the chain. So meron sila ng magkabilang dulo, ang tawag sa kanila ay bifunctional monomers. So ito yung mga kailangan dun sa ating formation of large molecules or dun sa polymerization. So classification of polymers, okay? So, una ay natural based on origin of source. So, ano yung mga ibang polymers? So, we have the natural, the semi, and the synthetic polymer. Okay, so source. So, dito muna tayo sa source. Okay, so next, ano yung mga classification? Okay, we have the synthetic or the man-made or synthetic polymers that are synthesized in laboratory. So, pag sinabi nating synthetic, ito yung mga ginawa sa laboratory or prepared sa laboratory. So, synthesized from small organic molecules such as nylon or polyethylene. Then, next is we have the natural polymer. Okay, natural polymer, ito yung mga found in nature. So, yung polymer, so nakukuha nyo na klase, it is a general term. So, natural, those derived from plants and animals such as starch, proteins, nucleic acids, and natural rubber. So, these are what? This contains large molecules. So, polymers such as polysaccharides, the starch, and cellulose. So, yun yung mga example ng polymer. Kasi minsan baka naisip natin na pag polymer ay those plastics. No, polymer is referring to what? Large molecules. So, starch is a polymer of alpha glucose. Okay, cellulose also, proteins. Di ba, pag inano natin yung mga structure nila, dugtong-dugtong yan na mga mahaba. So, nucleic acids, natural rubber is a polymer of unsaturated hydrocarbon of 2-methyl-3-butadiene, also called isoprene. Okay, it is obtained from latex of rubber trees. In natural rubber, okay, take note, in natural rubber, there are 10,000 to 20,000 isoprene units that are linked together. Okay, that are linked together. So again, it is 2-methyl-3-butadiene o ibig sabihin, alkene ulit siya. Ibig sabihin, meron siyang double bond. Okay, semi-synthesis polymers, cellulose, and derivatives of cellulose. May mga additives, no? So next is we have the source. Okay? So dun structure. So dun sa source, meron tayo yung natural, synthetic at saka semi-synthetic. Then under structure, okay, meron tayong under structure, yung kanina we have linear, okay, long and straight chain. Then we have the branch chain polymers. So nakita nyo yung pinagkaiba. Okay, linear. And then next we have the branch chain polymers. Linear are having some branches. Okay, these are considered the low density polymers. And then we have the cross-link. Okay, so mas complicated lang siya kumpara dito sa branch chain polymers. So the cross-link polymers form from bifunctional and trifunctional monomers and contains strong covalent bonds. Okay, bifunctional. Ano nga ulit yung bifunctional? Yun yung magkabilang dulo ay may mga functional groups. Okay, see, Paul and Pablo. So example, so form from bifunctional. So pag ganon ay they are what? Isang characteristic nila ay they contain strong covalent bonds. Okay, so next. So, ano yung sa structure ulit? Okay, structure we have what? The linear, the branch, and the linear, branch, and the cross link. Okay, next, we go to polymerization. So, sa source, we're done with the source, we're done with the structure, tapos punta tayo sa polymerization. So, under polymerization, one is we have the addition polymers. Okay, addition polymers, they are formed by repeated addition of monomer molecules possessing double or triple bond. Okay, so this is the combining of ethylene monomer. So, pinagdugtong-dugtong yan. So, nangyayari yan by what? By applying heat or pressure or in the presence of catalyst. So, ang tawag natin dito ay addition polymers. Okay, next is we have the okay, mamaya natin ito puntahan. Addition. Next is we have the condensation polymers. So, condensation polymers formed by repeated condensation between two different bifunctional or again trifunctional monomers. Okay, so ito yung inano kanina na yung COOH nila, yung dalawang functional group ay nandun sa magkabilang end. Okay, extreme end. So, kumbaga dun sa dulot-dulo. Okay, so in this case, we have condensation of condensation polymers when one of the hydrogen and the OH combine. Okay, pag nag-combine sila, then forming now this one. A bigger molecule. Okay, bigger molecule. Ito yung kanina. We have the COOH and we have the alcohol. Pag pinagdugtong, ito na yung tawag nito. Right? So, yan na yung na-form. Kaya lang, nung na-form class, so natanggal yung water. So, dito sa condensation polymers, meron tayong byproduct. So, isa sa byproduct natin ay water. Okay, pag nakita nyo class, di nag-form sila, di ba? We have the OH. Pag na-form na, yung magkabilang dulo ay still what? There are still what? Functional groups. We still have the COOH and we still have the OH. So, pwede pa rin siyang makipag-join ulit sa ibang molecule. So, resulting to a repeated joining of molecules. Okay, so ang tawag doon ay condensation process of polymer. Formed by the condensation of two or more monomers with the elimination of simple molecules like water. So hindi lang water, it could also be an ammonia or hydrogen, chloride, or alcohol. Basta, ang sa condensation polymer, meron siyang byproduct. Meron siyang natatanggal pagka nag-join yung dalawang molecule. Okay? So, eto naman yung sa joining. So, ang natin dito is we have the NH2. Di ba yung kanina ang ating functional groups ay COOH sa alcohol. Ang dito naman is we have the amine. Okay, NH2 magkabila tapos combined with what? COOH. Magkabila din. Okay. So, nag-join yung NH2 at saka yung CO, yung isang N nito. No? NH2 at saka yung isang N. So, we have now a repeated. So, how many? We have CH2. We have CH2-6. The hexamethylene diamine. Or we have the product now is we have the nylon 66. Okay. So again, OH and OH, OH and OH then. So again, one of the byproduct is what? One of the byproduct is water then. So ang ano naman natin dito is the dacron. So yan yung mga polymers. Okay, polymerization. Okay, so eto na yung kanina. Balik ko nga dun sa slide na nauna. Okay, we have the addition polymers. Eto na yung polymerization process. Okay, polymerization process. Okay, so balik tayo doon sa polymerization. So one is we have the initiation reaction. Okay, initiation reaction. So we have one is we have the chlorine gas. So we have chlorine gas that is an existing gas. Chlorine gas when it is heated or passed through a light, then nag-ano siya, naghihiwalay siya into two chlorine naghihiwalay siya into 2 chlorine atoms. Okay? Ang tawag natin dito ay molecule, ang tawag natin dito ay atom. So, naghiwalay sila, ang tinatawag na cleavage. No? So, with the presence of energy, either in the form of heat or light, so these 2 chlorine now will separate into these 2 kinds of atoms. No? Chlorine. So, ano ang importante dito sa paghiwalay? Okay, nung naghiwalay sila, ang tawag dyan ay homolysis, the cleavage of the chlorine-chlorine bond in a symmetrical way. Okay, so naghiwalay, producing similar atoms. And then, nung naghiwalay sila, nagkaroon ngayon ng, in the separation of the chlorine to chlorine, nagkaroon ng tinatawag na odd electron. Okay, odd electron or not paired and does not have a, it's not hindi siya nakaband. Okay? So, eto ngayon yung tinatawag natin na odd electron. Wala siyang ka-partner. No? Wala siyang ka-partner. Ito yung lone pair natin, lone pair electrons yan. So, eto ngayon yung odd pair. Odd electron.
Ang kulit mo naman.
So, does not have a partner of opposite spin. So, wala siyang ka-partner, unpaired. And so, ano ngayon ang nangyari, class? An atom or group of atoms possessing an odd electron is called a free radical. Okay? So, pwede siyang atom o pwede siyang group of atoms na merong odd electron. So, ang tawag natin dyan ay mga free radical. Okay? Free radical. So, ano ngayon ang nangyari? Ito na ngayon. Yung kanina ay initiation. So, ang kasunod ay, so, ito na siya. Ito si radical, free radical. Meron siyang odd electron. So, ready siya makipag-combine. Okay, ito naman ay open because it is unsaturated. So, it is open for bonding. So, pag nag-bond sila, so, pumasok si R. Kaya lang, pagpasok ni R, may na-produce ulit na panibagong odd electron. Okay? Lumipat lang siya, pero meron pa rin siyang odd electron. So, ibig sabihin, this one is still capable of, again, bonding. So, eto ngayon, makikipag-bond na naman dito. After that, may na-form na naman na odd electron. Okay, so series ngayon yan. Okay, so this is the initiation, yan. So, merong formation of bond. Sa initiation reaction, nakaka-form tayo ng odd electron. Then, we have when 2 active chain ends meet each other or active chain ends meet with initiator or other species with single active bond. So, eto na siya. So, this one, eto yung na-form natin, di ba? And then, meet with this. So, magkakaroon na ngayon ng terminal compound natin. Okay? So, that is what we call the termination. Okay, termination process. So, termination, chain terminating steps. So, pag nag-join yung dalawa, pag nag-join yung dalawang may odd electron, then that will terminate or that will stop the polymerization process. Okay? So, ito yung mga example ng termination. So, kanina we have the radical, di ba? Free radical ang tawag natin dyan. And then after that, we have now the molecules or the compounds. So, again, ano yung mga terms natin dito? Initiation, propagation, and termination. So, initiation, magkaroon tayo ng odd electron. Then, propagation, ito na yung pagdugtong-dugtong. Okay? So, pagdugtong-dugtong, that will produce, let's say, a long chain of mer units. Okay? Then, the last initiation, propagation, and the last one is we have termination. Kung merong dalawang compounds or radical containing, dalawang radical containing an odd electron na mag-combine, then that will be the termination. Okay, termination. Okay, so ano yun dito sa polymerization? We have the initiation, propagation, and termination. Okay, so ito yung nangyayari. So open siya, magjo-join dito, then, okay, so ito na ngayon yung Balik natin. Okay, eto si add electron. Nung nag-join dito, si add electron, lumipat na dito, di ba? Tapos, another double bond. So, makikipag-join siya ulit dyan. After joining, nagkaroon ulit ng add electron. O, nakailang form na siya. Tapos, another double bond, lilipat siya ulit dyan. So, nakailan na. So, that is the process of how these large molecules are being formed. Diba? So, chain initiating step, propagating, and terminating. In which energy, so sa chain initiating summary, in which energy is absorbed and then reactive particle generated. Yung mga reactive particle, ito yung mga radical natin. Yung merong containing the add electron. Then propagating, in of which consumes a reactive particle and generates another. So it consumes the free radical, but it could generate another. Then chain terminating, in which reactive particles are consumed but not generated. Okay, so initiation, propagation, and termination. So, ito na ngayon yung ating mga double bonds. Okay. We have the polyvinyl chloride, polystyrene, and Teflon. Okay, polystyrene and Teflon. Ito yung pwede mga ano natin. Ito yung mga ready to what? Ready to join with radicals. Yung mga double bonds. Okay, so tetrafluoroethylene monomer polymerized to form polytetrafluoroethylene or the PTFE. Okay, so yan. Okay, so difference between addition and condensation polymerization ay addition polymerization, it requires the presence of multiple bond, yung double bond at saka triple bond. Kung sa condensation naman, ano ang kailangan? We have the functional groups to be present at both ends. Okay, hindi ko lang nailagay. So, siguro i-ano ko muna bago ko ipadala sa inyo itong PowerPoint. Lagyan ko na lang dito yung pinaka-example. So, dapat ito may double bond, dapat ito ay may functional groups na nakadikit dun sa magkabilang dulo. Okay, ano yung mga functional groups ulit? Yung mga OH, COOH, and H2. Okay, there can be two monomers having multiple or bonds. Tapos ito yung, ito na pala, functional groups. So, ito yan, yung mga COOH. Then, next is no byproduct. Pag sa addition, no byproduct. Pag sa condensation, meron tayong byproducts ng mga water or ammonia and so on. So, homochain polymer, heterochain polymer, which may be either thermoplastic or thermosetting is obtained. Okay, these polymers have some atoms other than carbon atoms in the polymer chain. Okay, these polymers have only carbon atoms in the polymer chain. Ito yung sa addition na. Ito yung sa condensation. Okay, the growth of chain is at one end, at one active center only. Dito, group of chain is minimum at 2 active centers. Kasi nga ito ay open. Itong dalawa. Okay, so dito meron lang tayong isang end lang siya parate. Isang end lang. Dito, dalawa yung ating center. Active center. Yung magkabilang dulo pa din. Okay, so some polymers may be represented using the following generalized form where the R depicts either an atom again or hydrogen or chlorine polyethylene. No? So, next is polymerization. All right, we go to molecular force. Okay, so source, structure, polymerization, then we have the molecular force. So, under this, we have the thermoplastic and the thermosetting. Okay, so thermoplastic polymers. So under this, ano yung ano natin, yung last molecular force. Under molecular force, we have the thermoplastic and the thermosetting. So, soften reversibly when heated. Ang thermoplastic, hardened when cold. So, pwede na siyang, ang tawag to, solid na siya, pwede mo siyang iinit and then it will soften. So, pabalik-balik lang siya. So, pagka na-cool naman, harden, tapos if you want to i-ano mo ulit, baguhin mo ulit yung kanyang form, pwede mo siya ulit i-soften. Okay. And then, so most thermoplasts are linear polymers and some branch structures. Diba na ano natin yung kanina, linear. We have the linear, the branch, and the cross-link. So next is examples of this thermoplastic. We have PVC, Teflon, polystyrene. Okay, thermoplastic. Solid materials at room temperature but viscous liquids when heated to temperatures of only a few hundred degrees. Then, characteristic allows them to be easily economically shaped into products. They can be subjected to heating and cooling cycles repeatedly without significant degradation. Okay, so dalawa lang naman yung ating pinagkukumpara dito. You have the thermoplastic and thermosetting. So, ang thermosetting polymers naman or simply thermosets, yung kanina, thermoplast. No? Thermoplastic or thermoplast, thermosettings or thermoset. So, harden permanently, or irreversibly, no? When heated. Ibig sabihin, once it is heated, pagka solid na siya, hindi mo na siya pwedeng iinit ulit, tapos babalik siya sa liquid form. No? So, harden permanently when heated. So, it is covalent crosslinks of monomers formed during heating. Yung kanina sa thermoplast, it is what? Linear and branch links. So, cross-linking hinder bending and rotation. So, thermosets are harder, more dimensionally stable, and more brittle than thermoplasts. Okay, so ito yung example ng thermoplastics and thermosets. So, ito pwede pa siyang i-recycle ulit, i-heat, i-deform. But then this one, it is once it is shaped, it can no longer be melted. So, elastomers and fibers, polymers that have elastic character. Okay, so from the word elastic, diba? Elastomers, the polymer chains are held together by intermolecular forces. So, example of elastomer is we have the natural rubber. Okay, then we have the fibers. These are the polymers which have strong intermolecular forces between the chains. Either hydrogen bonds or dipole-dipole interactions. Ito naman yung mga fibers. So, sa elastomers, we have rubber. Sa fibers, we have the silk. Dacron or silk. They can be woven into fabrics. So, yung mga fabrics natin are under fibers. So, thermoplastic. Okay, thermosetting. So, we're done with this. Polymer types according to end use. Kung paano siya nagagamit. So, we have the plastics, elastomers or rubbers. We have fibers. Ito yung mga silk natin. Okay, then coatings, adhesives, foams, and films. Ayan. So, another is we have ito yung nakikita nyo sa mga anoplas, di ba? Ito yung mga nakikita nyo sa mga bottle, di ba? Ito yung symbol ng recyclable. Pwede pa siyang ma-recycle. Okay, so we have the PETE, HDPE. Ano ang mga meaning ng mga ito? Okay. Okay, so what do the recyclers mean? Bakit nilalagyan ng ganyan? Okay, one is what? It is a reference to what type of plastic the container is made of. So, ibig sabihin, pagka siya ay 1, eto lang siya talaga. Pagka 2, HDPE lang siya talaga. Hindi pwedeng 2, tapos naging B, tapos 2, naging PP. So, naka-designate na sa kanila yung kung ano yung number, yun yung kanyang material. Okay, another is, it is used in classifying the different types of plastics. and it aids recyclers in the sorting process. So different molecules do not mix when plastics are recycled. Dahil nga magkakaiba ang kanilang components, so pagka sa recycling, mas maganda siya kung halimbawa similar materials yung magkakasama. Okay, so that is ang isang reason dyan bakit meron tayong mga numbers dyan. So, ibig sabihin, pagka ni-recycle siya, sama-sama dapat lahat ng number 1, lahat ng number 3, dapat sama-sama. Hindi dapat halo-halo. Kasi nga, they are made of different materials. Okay, so punta na tayo dun sa ano ba yung mga 1 at saka mga 2. So, PET or PETE, that stands for polyethylene terephthalate. Okay, polyethylene terephthalate or polyester. So, ito yung mga example ng PET or PET. Ito yung mga mineral water natin, no? Okay, so it can be crumpled. Dito parang alam nyo na, doon pa lang sa itsura ng bote, alam nyo na kung ano nagiging property niya. So, these are labeled as 1. Okay, then we have the HDPE. So, anong meaning ng HDPE? That is the high density polyethylene. Okay, HDPE. So, compared to the other one, mas harder itong mga plastic na to. So, HDPE, so this is the high density, and then we have the low DPE, or we have the low density. So, high density, this one is low density. So, polyethylene. Okay. O maraming ethylene, yung dalawang carbon na pinagdugtong-dugtong, dalawang carbon na may double bond. Or the ethene, no? Okay, so polyethylene, then we have the polyvinyl chloride, or simply PVC. O pwede ring V, no? So, polyvinyl chloride. Okay, ito naman yung mga low density polyethylene or the LDPE. Okay, yung mga, ang tawag to, sa andobag, yan tawag natin. Then, you have the polypropylene. Okay. Propylene, magkaiba lang sila ng pinaka-components, no? Okay, polystyrene. Right, so yan yung mga natin. The PET, the HDPE, so high density. You have the polyvinyl or simply vinyl. Then you have the low density, the polypropylene, the polystyrene. Okay, and then 7 is no recycling potential. So kung mga terminal na yung pupuntahan niya, must be landfilled. Okay, so ito yung mga recyclable materials natin. So, ito na yung mga uses nila, no? Saan sila madalas gamitin. Okay, so next. Anyway, ito na rin yung kanina. So, bags, cheese, bubble wrap, toys, low density. Ito pala yung pinaka-source class. Okay? Ito yung mga ethylene. Ito yung mga double bond, di ba? Double bond, ethene, di ba? Ethene or common name niya ay ethylene. Ethene or common name niya ito. Ethylene. So, ito yung pinaka-source nila, yung pinaka-monomer. Yung pinaka-single unit. Okay, so vinyl chloride, it is also an ethene. Styrene is meron tayong, meron tayong benzene ring. Styrene, and then we have the polypropylene. Okay, tatlong carbon. Yung kanina, di ba, propane, propyl, propylene. So, tatlong carbon naman. Terephthalic acid. Okay, so plastics can be brittle or flexible. Okay, punta na tayo sa elastomers. So, na-discuss na rin natin ito kanina. Elastomers. Fibers. Alcarmen. So, fibers yan. Yung kanina, these are rubbers are elastomers. Okay, fibers. Then, criteria. Sana tayo. Coatings. Okay, ano yung mga coatings natin? Okay, ito yung mga example ng coating materials natin. Coating materials. So, applied to the surface of materials to serve one or more of the following functions. So, to protect the item from the environment that may produce corrosive or deteriorative reactions. Diba? To improve the item's appearance. So, aside from this one, yung pinaka-main ano niya is to improve the item's appearance and to provide electrical insulations. Okay? Di ba napansin naman, na-mention dun sa ating one way to prevent corrosion is applying organic coatings, and that is using paints. So these organic coatings fall into several different classifications: paint, varnish, enamel lacquer, and shellac. Okay, so coatings. Next, we have adhesives. Substance used to bond together the surfaces of two solid materials, o ang tinatawag na adherents. So, two types of bonding mechanism. We have the mechanical and chemical. So, mechanical actual penetration of the adhesive into surface pores and crevices. Chemical naman involves intermolecular forces between the adhesive and adherent. So, mechanical, natural adhesives, eto na yon. Familiar naman klase yung mga ano to, di ba? Yung mga gamit na ganito. Adhesive materials based on synthetic polymers. Natural adhesive, eto naman yung mga synthetic adhesives. Okay, so yan. Polyurethanes are thermosets. Thermosets, yung hindi na pwedeng i-reverse, hindi na pwedeng painitin at lalambot siya. Okay. Polyurethanes, a type of elastomer which is capable of experiencing large and irreversible elastic deformation. Polyurethanes. Okay. The underlying chemistry behind polyurethane was first developed by Professor Dr. Otto Bayer. Okay, forms of polyurethane: flexible, solid, and foams; rigid, resins, tabletop, covers, furniture, and furniture protection. So, ito yung ating mga polyurethane. Okay, so ito yung pinanggalingan. Polymers like this in the form of resin. So usually class, ang pinaka-raw materials natin sa mga ganito, ito yon, yung mga resins. No? So, ito yung mga raw material, tapos dinidissolve o minimelt para magkaroon siya ng mga ganitong gamit, no, materials. So, syempre, iba-ibang kanilang shapes, depende sa kanilang ibang shape, depende sa kanilang gamit. Okay? Kung kailangan mo ng hard material or pwede na yung soft material. Okay, so polymer processing, we go to polymer processing. Ito yung pinaka-again, ito yung pinaka-raw material, and these are the finished products. So, tingnan nyo, magkakaiba. Ibang-iba ang kanilang, tawag nito, iba-iba ang kanilang itsura. Ibang-iba. Okay? So, these are now the different processes or polymer processing. So, we have extrusion, compression, injection molding, okay, 3D printing, blow molding, casting, thermoforming, okay, or rotational molding. So, ito yung mga iba-ibang processes. So, halimbawa, ito yung material, ito mo gusto mo pipe. So, siyempre, iba ang kanyang process na dadaanan. So, extrusion. A process technique for converting the thermoplastic materials in powdered or regular form into a continuous uniform melt shape into items of uniform cross area by forcing through a die. So, ang tawag natin dito sa pag-produce mo ng mga pipes class is extrusion. Extrusion. Yan. So, ito si extrusion process. So, ito yung papasok yung raw material natin, yung resin, yung pellets, yung kanina. And then, so heater, meron tayong heater dyan. O, pasok dito ngayon ang mechanical, di ba? Mold and die. Okay, so yan na. Shaping die. Okay, so eto na yung mga products natin. So, tubing and pipe, sheets, and structural parts. So, extrusion. And then, we have also compression molding. So, kung ibang material naman, then you can use or you can utilize another process. So, pre-weighed material, meron tayo dito ngayon, heat and pressure applied to melt the powder and for it to flow into a parts of molding. Ito siya. Okay, so, upper movable hub, tapos, ejector pin. Sana kung mapuntahan natin yung mga ano, no? So, thermoforming naman, used for moderately complex shaped parts that are not suited for injection molding. So, too large and expensive. So, very thin walls. So, ito siya. Thermoforming. So, meron ka na dapat, ano to, parang pinaka-moldy material. So, casting naman, again, meron ka na yung pang-molde, tinatawag natin na pang-molde rin. So, naka-ready na siya, and then you just pour in the liquefied raw material. Liquefied raw material, or liquefied resin. So, resin is mixed with hardener, catalyst, or accelerator before pouring into mold. Para siya, ang purpose ng mga hardener natin or catalyst is para mabilis yung kanilang pag-solidify. Okay, mold is usually coated with a releasing agent such as wax, silicone, or oil. So, magkaano yan? Tawag nito, dalawang separate materials. Tapos, pag inilagay, eto na yung na-form, di ba? The solidified casting. Okay, pag nakapunta kayo class, halimbawa sa DOST, may mga ganito sila, no? So, let's say, ito yung required product. So, ginagawa nila, nagpo-form sila ng casting. Ito, yung mismo. Dinidesign nila. So, molecular, open cell, anyway, ito na lang siya. Molecular closed rings in polyurethanes. Okay, thermoforming, so bumabalik lang doon. Okay, so yun yung mga different processes natin. Okay, so ito pa rin siya, yun sa amorphous. Crystalline and folded molecule chains. So, hindi natin ito i-anahan dito class. Anyway, these are just what? These are just data for the different products. Low density and high density. So, kung ano yung kanilang pinagkaiba, difference in their properties. Hindi naman, kumbaga, hindi naman masyadong magkalayo ang kanilang properties, ang pinag-iba nila. Okay, so that is the end of our polymer. So we were able to discuss ano yung pinakasama rin natin, yung mga different types of polymers based on their sources, based on their structure, at saka kung paano sila na-form, di ba? Like mga casting, thermoforming, compression molding, extrusion. So it depends on the desired product. It depends on the desired product. Pero ang pinakaano lang naman dyan is what? You have the raw material and then you have the solid pellets and then it will be heated para maging liquid para madali siyang i-shape. So, extrusion. Okay, question class? Any reaction? Question?